New paradigm for maritime logistics. Mobile harbor. The KAIST Mobile Harbor, which allows reliable handling of containers between two ships docked to each other on a wavy sea, opens new era of maritime logistics for the first time in the world. The Mobile Harbor Project, a large-scale national project for the future technology development, has been funded with $32 million since 2009 and developed new fundamental technologies such as stabilized crane, automatic ship docking, and so on. All the outcomes should be the new thruster for maritime logistics. For the last 2 years, the Mobile Harbor Project has produced notable research outputs such as 176 international and domestic patents and 92 research papers, which all contributed to the fundamentals of the mobile harbor technology and industrialization of it as well. In the past, there had been a trial for loading or unloading containers at sea using a conventional crane. However, the operations are very dangerous and tedious since they have to massively rely on the human assistance. Moreover, the operations are only available at the calm sea. To overcome this problem, the KAIST Mobile Harbor realizes a floating harbor based on two core technologies such as automatic docking system, which can dock two ships quickly and safely, and stabilized crane, which allows the precision container handling in the open sea. When the mobile harbor approaches a container ship within the distance of fender, the robot arm of the automatic docking system carries a suction pad to the hull of a ship. Then the robot arm becomes passive with respect to the relative ship motions just after the suction force gets active. To maintain the stable docking state, the tension of the mooring cables is automatically controlled by the main winch system. When the loading and unloading tasks are completed, the suction pad will be swiftly separated from the container ship by removing the suction force. In an emergency situation, the robot arm quickly retracts and safely stores the suction pad. The automatic docking system is a core technology for a mobile harbor system that can dock between two ships quickly and safely, and thus allows the ship-to-ship cargo transfer regardless of the relative motion of ships owing to the waves and wind. Another core technology for mobile harbor is a stabilized crane for container handling, which employs 4 control systems. Swing-free control is for suppressing the movements of a spreader being suspended by ropes. After docking is completed, the multi-stage trolley approaches a target position on a container ship along the boom of a crane. The Smart Vision system measures the motion of a spreader by detecting the infrared markers on it. Observe that the trolley is a dual-stage actuator, which attenuates the swing motion of a spreader effectively in the traveling direction and in the traversing direction as well. Moreover, the rope-reeving system of the trolley is creatively designed to mechanically compensate the heavy motion of the spreader induced by the dual-axis motion of the trolley. The heave control system is for keeping the constant distance between the spreader and the target container. It avoids the collision between the spreader and a target container by detecting the relative motion between the ships in the vertical direction. The spreader alignment control is for grasping the target container accurately by controlling the position and posture of the spreader. The precision position tracking control is achieved by the 3-axis actuation of the spreader, based on the information from the sensor fusion system on the intelligent spreader. The sensor system detects the shape and position of the target container in real time. Finally, the spreader tilting control is for keeping the horizontal posture of the spreader with respect to the target container. It utilizes the tension and rope length control for the individual rope, based on the tension controller. All these state-of-the-art control systems in the mobile harbor allow efficient and reliable container handling operations in the wavy open sea. They extended for building the offshore plants, replenishment operations at sea, special purpose crane, rescue operation at sea, and etc. The KAIST Mobile Harbor, new paradigm for a maritime logistics system it will take a role to advance the 21st century technology paradigm for South Korea to be a leader in ocean engineering and industries over the world.